Yogeshwari. Welcome to our channel for the second video. Sorry for the late upload and thanks for the positive comments. Guys, I'm happy to welcome you all for the video series on engineering physics. Let us begin with properties of matter, and the topic of this video is stress and strain. We know that physics is a branch of science which deals with matter. Matter is one which occupies space. Different materials behave differently. Certain materials are very good conductors of heat and some materials are good conductors of electricity. Some will behave as magnetic material and some will behave as non-magnetic material. So it is important to study the properties of matter by which we can use them for different applications. So here we will discuss about stress and strain. When a force is applied on a body, definitely that body will be deformed. For example, if we take a rubber band and we stretch it, the rubber band will be, that is, the shape of the rubber band will be changed. And the force which is used to deform the shape of the rubber band is called deformation force. When a force is applied, a deformation force is applied on the rubber band. An equal and opposite force will be set inside the rubber band, which will help the rubber band to regain its original shape. This force, which is developed inside the rubber band, is called as a restoring force. That is, the internal resistance set up by the body when it is deformed develops a force called as a restoring force. So, if the restoring force developed inside a body is equal to the deformation force applied from the external, that body regains its original condition. These type of bodies are known as elastic bodies, like a rubber band. At the same time, if a material like a volcanic putty, the restoring force developed inside it will be less than the deformation force applied from the external world. So this type of bodies do not regain their original condition even after the removal of deformation force. So that type of bodies are called as plastic bodies. So the internal force, that is the restoring force developed inside the material, which will help the material to regain its original shape per unit area, is called as stress, which is having the unit of Newton per meter square, and sometimes it is represented by Pascal. So there are three types of stresses. One is called as normal stress, next one will be the shearing stress, and third one will be the volume stress. The normal stress is defined as if a force is applied in a perpendicular to the surface of a body, then the stress developed is called normal stress. And the shearing stress is defined as if the force is applied along the surface of a body, then the stress is developed is called as tangential stress or shearing stress, as shown in the diagram. It is also called as sideways stress. Coming to volume stress, the stress that occurs in a material when it is subject to compression from all sides represents a volume stress as shown in the figure. Now let us switch over to the strain. So on an application of a deformation force, your body gets deformed. Either it may be stretched or it may be compressed or twisted. As a result, the dimension, like the length or its angle or its volume, changes. So the strain is defined as the ratio of change in dimension to the original dimension of a body which is having no unit. So here we have three types of strain. One is longitudinal strain, next is called as shearing strain, and third one is the volume strain. Coming to the longitudinal strain, it is defined as the change in the length of a deformed body to its original length. Whereas the shearing strain is defined as the change in angle to the original angle. And the volume strain is defined as the ratio of change in volume of the body to its original volume. Thank you.